All right, we are live. Welcome, everybody, to the Gunner Technology Livestream, a weekly tech talk for non-techies and techies alike. I'm your host, Terry Merkins. With me is CEO of Gunner Technology, Cody Swan. What's up, Cody?
Not much, just putting in a last-minute change, pushing a last-minute change before the show.
It's always the best time to launch something. It's right before you're going to be on for half an hour.
Yeah, that's exactly right.
So we're going to be doing something a little bit different starting this week. For the next 10 weeks, we're going to be going through various case studies that we just started filling out for the Amazon Partner Network. So we're going to sort of walk through 10 different products that we've worked on or built over the years. But I guess before we get into that, we can shout out to our sponsor, Country Shore Outfitters. You can visit them at countryshoreoutfitters.com. They're a lifestyle brand for anyone who loves the outdoors. And you can sign up on our Facebook page for the Country Shore giveaway, which this week I just realized I need to look it up. Who won this week? I had it right here. John L. from the Midwest. I think they get the best weather in the summer. So, John, enjoy the weather and enjoy the Country Shore hat heading your way, along with our new ebooks, which there's going to be a new ebook launching at some point this week. It'll be our ebook about careers in technology. So keep an eye out for that, everyone. And John L., enjoy your Gunner Technology ebooks and your Country Shore hat. And while you're on our Facebook page signing up for the Country Shore giveaway, you can answer our question of the week, which, Cody, what was the question of the week last week? Actually, I remember. It was how many apps you use.
Yes, that's right. How many apps on your phone do you use on a weekly basis? That's right. And it looks like we're kind of getting answers like all over the place because I have quite a few actually. I'm pretty high, and I thought I was going to be pretty low. Like on a weekly basis, I use every app on my home screen, which was 12, 16, about 20 apps, and I'm on the high side.
Do you have apps on your home screen?
Well, I mean, you know how you can have multiple screens on your phone. The only ones that I use on a weekly basis are the ones that I have on the first screen.
I have all my apps at the bottom of my screen in one folder. And that folder's name is Nonsense.
Well, it's
I use 5 on a weekly basis.
And it is weird. I mean, I have the home control thing. I have my gym membership, my clock, my calendar, Spotify, weather, mail, phone, messages. And then we have like development stuff. So if I didn't have development stuff like Expo, then the apps we've developed, because I check in on them, they would be far less per week, but I kind of count those in there too.
Well, yeah, it's a bit open-ended question. Do you count settings as an app?
I think so. Anything that has a little tile thing on it.
Mine might be higher then.
Yeah, we consider.
Mine might be a bit higher. What were the range of answers that we got?
2 to 40, 2 to 39. I remember.
Why do you have a phone? 2. I guess, yeah, just use it as a phone. Would be 2.
Text messages, phone. And
yeah,
text messages.
yeah. I guess that makes sense.
And
what was the high? What was the high number we got?
39.
Goodness gracious me. That's a lot of apps to use on a weekly basis.
Yeah, I definitely have more than 39 installed on my phone, but my gosh, not on a weekly basis. There's no.
That's impressive.
I know. Gosh, I have some stupid stuff on here. Chow Cab is a good one. Chow Cab is a good one, man. You can order food fast from Chow Cab.
But this episode brought to you by Chow Cab. You can order food fast from your phone.
Oh man, I have some stupid stuff on here like Insta Cleaner because I was trying to delete all of my Instagram posts.
I thought that would have been like a cleaning service app.
Yeah,
just bring someone out to clean your house on demand.
After I order food from Chow Cab.
Yeah, come clean up.
I have Insta Cleaner come clean up my desk.
Oh, there's a business opportunity there.
Oh man. This week, this week, sticking with that theme, if you could only have one app on your phone, what would it be?
One app on my phone. Be the clock app at the timer. I use that. It's nice not having to have a stopwatch. That's my answer.
I'm going with Chow Cab.
I can't live without Chow Cab.
I think I would have to go with email. I mean,
you can check your email on your laptop, though. I guess you use a laptop, but what's nice about having a timer or the clock app is that it's nice to have without a laptop nearby. Like I think most of like messages, most of the text messaging stuff, email, all that stuff can be duplicated on a laptop, but you can't really drag a laptop around while you're timing stuff. Like I use my timer at the gym, so I don't want to bring my laptop to the gym.
Yeah, that's a good one. No, I think
Thank you.
I actually use the timer is a good one, but the timer at the gym is a specific good use case of the timer. The mail, I think I respond to mail more on my phone than I do.
Oh, absolutely, 100%.
Laptop, because like
Yeah,
I try not to, when I'm at my laptop, I try to shut down all other distractions if I can. So I'm actually trying to avoid email while I'm at my desk, and I try to do like email in a multitask environment, like when I'm doing cardio or when I'm going to the bathroom or
right.
all those things. I try to save my emailing time to check in those kind of batches, so I'm not constantly going back and forth to email.
I'd say stipulation is that it can't be an app that you have to use on your mobile device. Like we have authentication apps, like Google Authenticator, where you have to use it on a mobile device. So don't include that.
By the way, a quick PSA. Man, I was reading about how easy it is to break two-factor auth with SMS yesterday, and it is crazy easy. It is crazy easy, and actually Reddit got hacked big time through that exploit, and that's kind of why I was in the news. I knew it was a little bit iffy, but I had no idea how easy it was to. Now they have these things called they're called, I can't remember the technical term, they're called like sharks, and they basically just sit between cell phone towers and can basically just easily read messages as they go from phone to cell phone tower to other cell phone tower to other phone. They can just easily read those messages, and apparently leave it to our industry to come up with a fancy word for a word that's been around for a long time. It's open to social engineering. Well, what is social engineering, you ask? It's basically, so they did a lot of videos where people would pretend to call, or they did call like Verizon, and they would like have a baby crying in the background, or the sound of a baby crying in the background to kind of annoy the person on the other line. And they would basically convince the person, the operator, the Verizon operator, to change the phone number to their SIM card. So then that phone number then goes to that SIM card.
Oh my gosh. It's like the Mortytown Locos having a crib in the room.
That's right. That's right. So, I mean, don't abandon two-factor auth through SMS for nothing. But like you said, Google and having like an MFA device is much more secure than SMS.
That's nuts. That's a solid public service announcement, though.
Yeah, I think so.
So let's dive right in with our first case study. We have an awesome app that we built to talk about today, and that app is Class Act Sports. Class Act Survivor is actually the product that we built. So why don't you just run through, I guess, what the gist of Class Act Survivor is?
Yeah, so Class Act Survivor was one of a suite of fantasy games under the Class Act Sports umbrella. And so I would kind of ease into it from the beginning. It's a fantasy sports application, and there's a very common type of fantasy sports application, or fantasy sports games rather, called Survivor games. And in Survivor leagues, what you basically do is each week you pick a team to win. All they have to do is win. So like, let's say in week 1, you have the Falcons and Patriots, and you pick the Patriots. If the Patriots win, you move on to the next week.
But that is a terrible game to pick for a Survivor pool.
Totally.
What are you, nuts?
so
basically, yeah, as an aside, always pick whoever's playing the Browns.
Right.
As long as you can.
That's right.
Anyways, sorry, I cut you off. That's a little bit of a tangent, but so you pick a winner each week, but you can't pick the same winner twice.
Right. So if you pick the Patriots against the Falcons and the Patriots win, you move on to the next week, but you can never pick the Patriots again the rest of that season, which is why it's a dumb pick, because number one, it's a good game, and really it's a toss-up who would win, and you've burned the Patriots in the first week, so you can never use them again later in the season. That's how survivors work, and usually they're done in leagues, meaning like teams or like players from like 2 to, I don't know, 100. I don't even really know what the cap is. So the difference with Class Act Survivor was that instead of picking teams, you would pick players, and those players would have to hit statistical achievements. So in week one, and the leagues would be, each league would have a different statistical category. So League One might be rushing yards and passing yards. League Two might be rushing yards, passing yards, and receiving yards. And so basically, what you have to do is pick a player to hit the milestone markers. For rushing, I think it was 100 yards. For receiving, I think it was 100 yards, and for passing or throwing, I think it was 200 yards. So let's say, take that example of the Patriots. Let's say they could be on different teams. So let's say you take Matt Ryan to throw for 200 yards and LeGarrette Blount to run for 100 yards. Well, if they both make those milestone markers, you move on to the next week, but you can never pick Matt Ryan or LeGarrette Blount again through the rest of the season. If you don't reach one of those milestones, you're eliminated. And usually these leagues have cash prizes for the last person standing.
And so what was the technology stack like that we used to build out Class Act Survivor?
Yeah, so this was actually one of our earliest kind of serverless models, which was perfect for this. And in a serverless setup, basically, we've talked about it in the show a little bit, but not to get too technical, but it's basically situations where you're not operating any servers of your own. You're basically running each kind of function or functionality on its own separate module called a microservice. And these microservices run on someone else's servers that are like bulletproof. In our case, it's AWS. So AWS handles infinite provisioning and infinite scalability of these microservices, provided you follow their configuration parameters. So this was cool because we had like microservices for parsing each type of data feed. So we had to get the data from somewhere in terms of like game scores, game time, obviously the player stats. So we had a microservice for every type of stat, and it would parse the service. And then we had microservices to retrieve the stats and munge them, combine them with the data that we've had, that we have in our league. So if someone picks LeGarrette Blount, for example, our database may show that that's a correct pick or an incorrect pick, or an in progress pick, and we'll match that from the data retrieved from another microservice with how many yards he has rushed for to see, and what the game is. If the game's in progress, then he can't have failed yet. So we would combine the data to determine whether a pick was correct or incorrect.
So what are the benefits of using microservices as opposed to sort of the old style of just a constantly running server that's, I guess, really active on a Sunday when all these games are being played?
Yeah. So it's, people don't actually really believe it, but it's almost like a silver bullet in terms of it solves the problem of scalability, number one. So let's say you launch Class Act Survivor and you're running it on, you don't have a lot of money because you just launched, you're an entrepreneur just trying to start this up. So you launch this on a single server, and because you're not anticipating a lot of people because you're just launching it. And then say Tom Brady tweets out, hey, I suggest everyone go pick me on Class Act Survivor. Well, everyone goes to Class Act Survivor, and you have one piddly little server that can't handle all these requests, and it just dies immediately.
Or Giselle tweets that you should pick her husband.
Exactly. So
the issue is that, and we've seen this firsthand, and it sort of happens time and time again, that the second your application gets attention, the one time you don't want it to crash, when everyone is trying to use or learn about your server, is like the service is the one time that your server does crash.
Right, exactly. And so the serverless model solves this completely. And so again, in the first situation, you could be like, okay, we're anticipating a whole bunch of traffic, so we launched a fleet of 50 servers. But then what happens if Tom Brady never tweets? We wasted a ton of money, and I mean a ton of money, for no reason whatsoever. With serverless, and so there's actually kind of another step that happened before serverless, which was kind of auto scaling. And so auto scaling would detect certain amount of metrics like number of connections, meaning number of people on the site, CPU utilization, memory utilization, and would kind of slowly bring up more servers in conjunction with that. The problem is it takes about 5 minutes for each server to launch, and it takes about 5 minutes for the metrics to kick in. So you're talking about 10 minutes to bring up one server and the next. So that's not ideal anyway either.
And there's a bit of a chasing your own tail there thing too, which is in the time that it's taken for that to spin up, there's been so much increased load on the server that exists that it probably went offline. So you need to spin up another server because that one went offline. And then you just can never really catch up to the traffic that you're seeing.
Correct. Yeah, exactly. And so with Lambda, which is the serverless platform that AWS offers, or part of the serverless platform that AWS offers, it's instant. It's when one of these functions fires up, it's held in cache, and as long as it's called within another 5-minute period, it doesn't even have to spin up another function. The same function is just called over and over and over and over again, and it scales out like this instantly. Meaning, like if 500,000 people hit the site, then 500,000 microservices spin up immediately. Every single request is handled by a different microservice.
Yeah, and I think it's important there when you say instantly, it actually is, for all intents and purposes, instantaneous.
Milliseconds, yeah. And the other thing, because the microservices, those functions are only one aspect of it. The other thing we use AWS for, because let's say on the other end, you have these functions that scale up and handle the request. You still have a database in the back end, which has to be able to handle all that traffic. And so if all of these functions, if it goes from like one function to 500,000 functions, and they're all connecting to a traditional database, the database could tip over and you would still have an outage, even though it's handling all the requests can't get any data back. So in that sense, we also went serverless with something else on AWS called DynamoDB. And DynamoDB is kind of the same thing as Lambda, but at a database level, where it has infinite scalability, provided, again, this is where I was like with the caveat that you configure it correctly. Provided that you configure it correctly, it will scale infinitely, and it will keep like replicating the data. And so there's no bottleneck. You're not going to ever run into a situation where you're overloading the database.
I guess what's the bottleneck with traditional databases? Why do they turn over? What's the problem there?
So again, a database, it just sits on a server. It just sits on a server. So databases have like limited connections, a limited number of connections. So that's one bottleneck. So if a database can only hold 2,000 simultaneous connections and there's 500,000 people, then people are going to have to wait to get that data back out of the database. The other thing, again, even if it's servicing the request fast enough, if it's not releasing the resources, it's going to run out of memory. And when it runs out of memory, it has to be restarted. So if the database runs out of memory, no one is getting their data back.
And I guess that's an instance too where the traditional method would be to have what's called a master slave setup, where you have certain databases where you just read data from those databases, and you have what are called master databases where you're actually writing stuff. So if somebody makes a pick, you would write that pick to the database, it would replicate out to the slaves, and then if anyone wanted to see what pick somebody made, they would just read from the slaves. And in terms of trying to get in front of massive traffic increases, you can have as many slaves as you want. So you would try to set up 100 slaves and replicate the data out to them to divvy the traffic up to handle the 500,000 people who might be using your site. But then again, there's the issue of maybe Tom Brady never tweets and you just wasted all this money spinning up all these databases that you didn't need.
Exactly. And also keep in mind that's another form of scaling horizontally, which is great, but it's only scaling the reads horizontally when people are requesting data from the database. This was a very write-intensive application because we were constantly parsing data from the feed provider and writing it to our database. So you can't scale. You can, but it's a much different, more difficult problem to scale a database, a traditional database, horizontally versus just provisioning capacity for DynamoDB to handle an infinite number of writes per second.
We've got a good question here. All of this serverless technology is pretty new. How thoroughly tested is it? Which is, I mean, how viable is this solution going forward? You call this silver bullet, and I tend to agree, but it has sort of only caught on just within the last couple of years.
Yeah, so it's a good point. And so there are a number of hiccups that keep getting solved. And so AWS is we're biased. We're partners with AWS. but we're partners with them for a reason because they're the best. And so they pioneered this serverless model. And Lambda launched, I want to say in November 2014, which is around the same time that DynamoDB. The interesting thing about DynamoDB, and we talked about this, is the actual name of Lambda is AWS Lambda. DynamoDB is Amazon DynamoDB. And I think the reason, I don't know for a fact, but I think the reason was DynamoDB was used for a long time by the retail site of Amazon. So it was released to the public in 2014, but it had a long time to have the kinks worked out of it before it went public. The Lambda idea, this microservices, it's a lot newer of an approach. And so, like I said, there's the functions, when they spin up, they spin down. They stay in cache for about 5 minutes, and so they can be reused again. But if they're not, they spin down. So, for example, it creates a problem with traditional databases because traditional databases like to keep connections open to their client, so they don't have to keep reopening. I talk about connections. So, like if you're a user and you go to a site, the site will open a connection to the database and will keep that connection open for the duration of your visit on a traditional setup. In serverless, it's going to open that connection, close it, open that connection, close it, open that connection, close it. And that presents problems for traditional databases. And so now they're working on ways to solve that. They have an intermediate, like a middleman kind of thing, who just will keep the connection open in the middle and will route other connections from Lambda through that middleman. It's called PG bouncer.
Is it a shark? Is it a shark like the SMS stuff?
It'll read your text messages. And then even AWS is they're launching something else. They've already launched it. It's a traditional database, but it's serverless, and we haven't played around with that yet. And that gets around the problem as well. So it's Lambda was one of the big things, hot new things in 2014. And it has been used so much by some of the biggest players, Airbnb, Netflix. There's some other really big names out there that have been using it. So the technology itself is pretty bulletproof. It's interesting, though, that you mentioned testing, because one of the things that is difficult with microservices, especially serverless microservices, is testing your code on them, not necessarily testing Lambda, but testing your code on Lambda. The reason being is because when in a traditional setup, you create what's called a local environment. Everything's running on your local environment. And so you test it there. You can't run AWS Lambda on your local environment. There's ways you can kind of get around it. But one of the difficult things involved with Lambda and microservices is creating a good local environment for testing and development. You get around it by creating you basically clone your production environment, which is remote, and you use that to dev off of, so you're not working on the production stuff. But it's not as easy as having a copy of everything on your local machine.
Just looking up here about Netflix on Lambda. And before they switched to Lambda, their stack was 50,000 instances in 12 zones, 50% of which turned over daily. So I think that's one instance where Lambda makes a lot of sense, it seems, as opposed to just turning those servers over constantly.
Did I tell you how much Netflix spends on AWS?
Oh, yeah, I meant to ask you. Yeah. Do you have that number handy? Because it's absolutely unbelievable.
$25 million a month. $25 million a month on just infrastructure. And they're not even 100% AWS. I think their total infrastructure bill is like 42 million, and 25 million of that goes to AWS.
It's pretty incredible. But I guess it makes sense with as much traffic as Netflix drives.
Yeah.
It's like 10, 15% a night is just Netflix.
Insane. By the way, it's not Netflix, Hulu, but Castle Rock, great show. Stephen King, J.J. Abrams, amazing show.
Is it about from a book, or is it new
not
material?
From a book. It's J.J. Abrams is the executive producer, so it's kind of his story. But Stephen King collaborated with him, and there's so many references in the show from Stephen King books. It's a lot of fun. It's a lot of fun to try to pick out all the Easter eggs. That alone makes it worth a watch.
There are some good ones in Lost too, not to go off on a total tangent, but I remember there was an episode of Lost where they had a rabbit in a cage with the number 6 on its back or something like that, which is straight from Stephen King's book On Writing, which is basically, he gave you that prompt, which is there's a rabbit in a cage with the number 6 on its back. Like, explain how the heck that happened. So obviously huge fans of Stephen King. What are some gotchas with transitioning to a serverless stack? What are some issues that people should watch out for?
So, like I said, testing or local environment setup, that's one of them. One thing that can be a blessing and a curse for serverless setups is the ability to use whatever technology you want. And what I mean by that is if you have like, let's say you have 3 microservices. These microservices, they don't talk to each other directly at all. So you can have one microservice written in like Python, another one written in JavaScript, and another one written in .NET, which is great. That's actually really cool for a lot of reasons. However, if you're a small firm and you have some guy who's like, I love .NET, and he writes his microservices .NET, well, everyone else is writing JavaScript, and the .NET guy bails. Well, I mean, you got to have someone who knows .NET to kind of support those microservices. That's been one of the things that I read as a gotcha as well. And
I guess that's sort of a bit of a plea to just use JavaScript at this point.
Yeah, exactly.
And maybe Python for data stuff, I guess. Sorry, I keep cutting you off, but no, it's tough. It almost seems like it's in your best interest to sort of convene on 1 or 2 technologies and have everyone in your company use it just for future proof.
Yeah, well, but the cool thing about that though is like if someone, so for example, if someone has an amazing machine learning microservice, it's probably written in Python, and you can literally just take that microservice, it's just one function, put it into your stack and shoot it up there. That's the really cool thing about that. So you don't want to say, like us, we're 100% JavaScript, but that doesn't mean we're not going to use some open source. We're not going to use some open source Python function in a microservice stack kind of thing.
That is a huge benefit, the plug and play ability of microservices.
And then I read somewhere, and I spend way more time reading this stuff than you do, and sometimes I question myself. But I read someone who it was a fairly big operation, nothing like a brand name like Netflix, but they wrote this long blog post about how they were abandoning microservices, going back to the traditional stack. And I read their reasoning, and it was basically just the fact that they were violating basic principles of programming. So like a microservice, like I said, it's just a function. And one of the basic things in computer science, which I even know this, is the contract that a function fulfills. Given these inputs, you will get this in return. That's called the contract. And so basically their big gripe was that with all these different microservices, their developers started changing the contracts. And so then this microservice talk to this microservice would break, and they wouldn't know why it would break, why it broke. And it was tough to track down the fact that, well, this function over here changes contract. That was really what it boiled down to, is their big gripe. And it's like, well, that's not a problem with microservices. That's a problem with people not following basic coding and programming principles.
I mean, it's tough too, because it sort of is a new paradigm. I think a lot of people have learned how to program from a more, I guess, a looser style of development. And there do seem to be more explicit rules about given inputs, your function should return the same thing every time, which is important for stuff like serverless, but that you can sort of hack and get around in older school methodologies of development.
Right. And this immutable, it's called immutable, is basically immutable functions, and it has a lot of benefits because you can do what's called memoize them, not memorize them, memoize them. And basically
and memorize them. I mean, you could memorize them too.
You could. And that's kind of what that's kind of what
actually
happens.
Yeah. Right. Yeah.
The function looks at the function runs once, right? It like takes the parameters, say the arguments or parameters passed to it are 1 and 2. So, and the function's called like eat pizza. So it creates this key called eat pizza 1, 2, and then it runs the function and it sees what's returned, something like full stomach or something like that. And so then if someone else calls the function eat pizza with 1, 2, it doesn't even run the function. It just returns full stomach. So it has a lot of performance benefits as well. It's not always possible because sometimes you are reliant on external data sources within your function. But generally speaking, it's the way that microservices should operate, because they are communicating with other microservices and they don't know what other microservices will be consuming them, kind of thing.
So just to wrap this up, do you have any concluding thoughts on the experience with developing Class Act Survivor?
I mean, it was, so we did an agile approach and it was difficult. And it's one of those things where you never have a good answer for it. Our client was great, However, he was much more into aesthetics than functionality. And so it was one of those things we talked about in this program before, where we kept dragging it out because we were doing pixel pushing after iterations. And so, like, what I mean was, could you make a pick? Yes, you could make your pick. Was it sexy and like flashy and you could move stuff? It had like slick animations and stuff? No. And what we always try to encourage is get a functional product that will work. There's always going to be people complaining that it's not easy to use at first, but getting it to usability is so much more important than getting it too easy to use. And so you have to basically have milestones where you're saying, okay, this is product V1. Now we're going to go back and refine V1. But you have to do new features and refinement in separate stages. And this project got dragged out a lot because we were doing pixel pushing while we still had features to build. So that's like a little caveat. It's so hard to explain that to a client who sees something that bothers them. It really bothers them. And they don't want to move on until that thing that bothers them is taken care of.
It's tough, but it's good advice, because at functionality, at the end of the day, it's all about functionality. It's all about whether people want to use your app. And I guess part of that is the aesthetics of it. But I think the aesthetics of it are easier to fix, not only after the fact, but based on real user feedback, than sort of upfront trying to figure out what users would actually want.
Well, that's right. And no one wants to hear this, but machines can tell us what is better design than any other human being can. And if you get the product complete, you start coding in like A/B tests, and you really get to actually pin down what is good design. Because what I always ask clients is, what would you rather have? Would you rather have, would you rather have a wildly successful product in terms of it has millions of users, but you think it looks like crap? Or would you rather have something that looks beautiful but is a ghost town?
It's a Craigslist argument again. Mm-hmm. So I think that's going to do it for this initial episode of the case study series. Join us next Thursday at 1 p.m. Eastern time for the next case study that we're going to review, which is sort of TBD at this point. Check out the associated blog post where will we actually post the case study?
Yeah, we could just post the case study as the blog post. That's fine. Yeah, that'll work. That's
yeah. So if you're interested in checking that out, head on over to gunnertech.com and check out our blog. The associated podcast for this episode will be on iTunes shortly. Keep an eye out for a new ebook on careers in technology, which again will be released over the next couple days on Amazon, Kobo, Barnes & Noble, iBooks, and anywhere else ebooks are sold. Head on over to our Facebook page to sign up for the Country Shore giveaway. Country Shore is a lifestyle brand for anyone who loves the outdoors. Check them out at countryshoreoutfitters.com. And while you're there, answer our question of the week, which remind us again what that is, Cody.
If you could only have one app on your phone, what would it be?
And why is it the clock app? So that's going to do it for this episode. Check us out next Thursday, 1 p.m. Eastern time for the next episode of the Gunner Technology Livestream. I'm Derry. That's Cody. We'll see you next week.